All right, my secondary math 2 class, we are going to continue talking about inequalities. Okay, so inequalities are math sentences that are not equal, right? Sorry about my band-aid on my thumb. I sliced my thumb open last night trying to open up a can of green beans. So yeah, please excuse that. Okay, but inequalities are math sentences that are not equal, right? So in this case, in number 1, we see that the left side with this -9 is greater than or equal to. Okay, they are not equal unless it says or equal to. Okay, so they could be greater than or equal to. Okay, so let's go ahead and start with numbers 1 and 2, okay? So we are being told to solve each inequality and graph its solution. Okay, so notice we have 2 steps that we have to do here. First, we have to solve. Okay, then we can graph. Okay, so if I am going to solve this inequality, first thing I want to do is I'm just going to rewrite it down here so you can go ahead and solve it. Okay, so -9 is greater than or equal to x plus 6. Okay, so I'm going to start it the exact same way. I'm going to draw my line down my inequality sign. Okay, and we're trying to get rid of whatever is on the same side as our variable. Okay, so looking at the side with my variable is this x. I'm trying to get rid of this plus 6. So what is the opposite of plus 6? Subtract 6 or -6. Okay, so that's how we get rid of it. Whatever we do to one side, we must do to the other. Okay, so we bring down our x, that's all that's left. We still have our same sign, and we have -9 minus 6. What is -9? Take away 6 more. So we're getting more negative here. -15. Okay, so now that our variable is all by itself, we can go ahead and graph it. Okay, so what point or what number are we going to put our point at? I'm going to put my point at -15. We know that -15 is in between -16 and -14, so it's going to be right there, right? That's -15 right there. Okay, so now we can go ahead and graph it. Is it going to be an open or a closed point? This is going to be a closed, right? It has that or equal to, so it has a little extra. Okay, so we put our closed point. But now, what direction am I going to shade? Okay, so look really close. I taught you guys the trick where if the variable came first, then the sign will tell you which way to shade. The variable did not come first in this case, right? It is -15 that came first. So we can't say that we're going to shade to the right because we can think of this in 2 ways. So we're trying to figure out what numbers are less than or equal to -15. Okay, which numbers on our number line are less than or equal to 15? Okay, is -14 less than -15? -13, -12? No, these guys are greater than. Okay, so if it were greater than, that sign would be opening up to the x. Because it's less than, we know that we need to shade to the numbers that are less than -15. Okay, another way you could have thought of that is if you switched it around so that your variable did come first, right? So just rewrite your variable to come first. Make sure that your sign is still opening up, right? That gator is still opening up to whatever it wants to eat, right? In this case, it wants to eat the -15. Okay, so now that our variable came first, now we can say, okay, it's pointing to the left, we shade to the left. All right? Perfect. So now let's look at number 2. Okay, so this one looks like a 2-step, 2 steps we're gonna have to do to solve this inequality. Okay, so I'm actually going to, let's rewrite it right here. So we have 2 greater than or equal to b minus 6 over 5. Okay, so I'm going to draw my line down my inequality sign. And what is my first step for getting this b by itself? So we are looking at this side of my inequality because we need to get that b by itself. What is the first thing I need to get rid of? Okay, it's going to be this divide by 5, okay? Because think this minus 6 is attached to that, so it's closest to it. Okay, so we need to get rid of the denominator first. So what is the opposite of divide by 5? We times by 5. Okay, so we're going to times by 5 to both sides. Okay, so that's going to give us 10 over here, still greater than or equal to b minus 6. Okay, and just because we're out of space right here, I'm just going to rewrite it right here. So 10 greater than or equal to b minus 6. Okay, so now I can do my next step. So same thing, draw your line. Okay, my second step, I'm trying to get b all by itself, so I need to get rid of this minus 6. What is the opposite, or how do you undo minus 6? We add 6. It's going to give us our b all by itself. Okay, so we get 10 plus 6 is 16 on this side, is greater than or equal to b. Okay, so now we can go ahead and graph this guy. Okay, so at what number am I going to put my point at? Going to be at 16. Okay, so that's right there. Is it going to be an open or a closed point? Going to be a closed because it has that little extra, right? It's greater than or equal to. Okay, so we're saying that b, we can plug numbers in for b. b is less than or equal to 16. What numbers on your number line are less than? Which way am I going to shade so that the numbers are less than 16? Okay, it's going to be shaded again to the left because all those numbers you could plug in for b and it would still be less than or equal to 16 because you could plug in 16, right? Because it's or equals to. Okay, or you could have just flipped it so that your b came first. So b, okay, the gator wants to eat the 16 still, so b is less than or equal to 16. That sign is pointing to the left. Okay, so we shaded it correctly. Alrighty. Okay, so let's look at number 3. Okay, so number 3, we are now sketching the graph of these guys. Okay, but look at the signs. Look at the signs in 3 and 4. Are these guys inequalities or equations? These guys are equations, right? They have equal signs. So we're going to graph these linear equations, right? That's what we're doing today, graphing linear equations. Okay, so do you guys remember? Hopefully you do. So let's make this note right on the bottom of these guys. Do you remember slope-intercept form? Graphing linear equations that are in slope-intercept form. So let me zoom in so we can kind of make some notes right here. Okay, so slope-intercept form tells us two things. When the equations are in slope-intercept form, it tells us two things. It tells us our slope, and it tells us our y-intercept. Okay, so if you guys remember, the format of slope-intercept form is y equals, okay, notice it always starts with y equals. Y equals, y equals. Okay, so we have our y equals, then we have our m that's in front of our x plus our b. Okay, so notice instead of an m and a b here, we have a -3 and a -1. So what are those guys? Which one is our slope and which one is our y-intercept? Do you guys remember from last year? Which one, meaning is my m my slope or is my m my y-intercept? I know this is a review from last year. Your m is your slope. Okay, so whatever number is right in front of that x is going to be your slope. Okay, your b is your y-intercept. Perfect. Okay, so now at the bottom of our paper, so let's go to the very bottom under 5 and 6. Let's write steps for graphing. Okay, because whether it's an inequality or an equation, the steps are the same. Okay, so steps for graphing. First, always start with your y-intercept. That is your starting point. Okay? Your second step is going to be to use the slope to count to your next point. Okay, so those are our steps for graphing. Okay, so the first one, we're always going to start with our y-intercept. Second one, we're going to use the slope to count to our next point. Okay, so number 3. Number 3. Alrighty, so looking at number 3, let's actually identify which one is our slope, or what is our slope and what is our y-intercept. Okay, so over here, let's write what our slope is and let's write what our y-intercept is. Okay, so looking at number 3, what is my slope? What is the number that is right in front of the x? Okay, it's this -3. Good, so we have a slope of -3. What is my y-intercept? What is the number that's on the end of my equation, right? What's that b, my y-intercept? It's -1. So our starting point is -1. So our y-intercept is the point on our y-axis. Okay, our y-axis is always the axis that is going straight up and down. Okay, that's our y-axis, that is our x-axis. So your y-intercept is the starting point, so you're going to put your first point at that number on your y-axis. Okay, so we are going to put our first point, right, because our first step to graphing is start with your y-intercept. So we are going to put our first point at -1. That is right there on our y-axis. Okay, so now we are going to use our slope to count to our next point. So do you guys remember, let's make another note on our paper. We'll just make it right here, that's fine. You guys remember slope is rise over run, so you always have to rise before you run, right? So sometimes it looks like a fraction, sometimes it doesn't. Okay, if it doesn't look like a fraction, remember -3 can also be written as -3/1. Okay, so now what we're going to do is from our starting point, we're going to rise, always is on top, so rise first, and then run. So our rise is -3, so we're going to go down 3 from our starting point. So 1, 2, and 3, okay? Wait to put another point because we still have to run. We have to run 1. Okay, and there's our second point. Okay, we can also go backwards to make sure it's a straight line, right? So instead of going down 3, we can go up 3. 1, 2, 3, and go backwards 1. Okay, we could keep going. 1, 2, 3, and go backwards 1. Still a straight line. Okay, since my slope was negative, right, a -3, my line is going down and to the right. In fact, I want us to write that on our paper. Okay, so a negative slope goes down to the right. Okay, so negative slope goes down to the right. Okay, so now let's look at number 4. Okay, so the first things we want to identify in number 4 is what is our slope? Okay, and what is our y-intercept? Okay, so our slope is the number that is right in front of your x. So what is our slope for number 4? The number that's right in front of the x. -4, or you can rewrite it as -4/1, right? If you like seeing it as that rise over run. Okay, then what is our y-intercept? What's the number that is on the end of our equation, right? It's +4. So we know that our starting point, right? We always start with our y-intercept on our y-axis right there. So our starting point is going to be at +4 on our y-axis. So +4 right there. Okay, now we're going to use our slope to count to our next point. So we're going to go rise, -4. So we're going to go down 4. 1, 2, 3, 4, and over 1. And there we go. We can keep going, right? Go down 4 again. 1, 2, 3, 4, and over 1. Beautiful. Okay, connect those points. Make sure, I forgot to say this on number 3, but make sure you connect them with a straight line, and you put arrows at the end of those lines, because this line goes on forever and ever. Okay, so make sure those arrows are on the end of your line. Okay, beautiful. So those are linear equations. Okay, they have equal signs, they're equations. Now look at 5 and 6. Are these guys equations? Look at the signs. No. Okay, these guys are linear inequalities. Okay, so we're going to start it the exact same way, but finish it just slightly differently. There's just maybe one more step when graphing linear inequalities. Okay, but first, let's start it the exact same way. So for number 5, let's identify our slope and our y-intercept. So for number 5, what is the number that is right in front of the x? Okay, remember it's an invisible, creepy number. It is 1. Or you can rewrite it 1/1. Beautiful. Okay, what is my y-intercept? My y-intercept is that +3. Great job. Okay, so we know that our starting point is our y-intercept. So our y-axis, again, right here. So you're going to want to put your first point at +3 on your y-axis. So +3 is right there. Okay, now my slope is 1 or 1/1, right? Rise 1 and run 1. Okay, so from our starting point, let's go up 1 and over 1. Okay, you can keep going up 1, over 1. You can even go backwards, down 1, back 1, because it's still creating that straight line, down 1, back 1, and we're good. Okay, so connect those points with a straight line. Put arrows at the end because that line goes on forever. Okay, and now I want to make another note on the side of this guy. So notice, up top, our slopes were negative, so our line was going down to the right. Well, now our slope is positive. Okay, so in a positive slope, whoops, I totally just positive slope. Okay, now it goes up to the right. Okay, so negative slope, down to the right. Positive slope, up to the right. Okay, so this is where it gets, we need one more step. Okay, so our last step for inequalities, in fact, only step for inequalities is you need to then shade. Okay, so just like up here when we were graphing inequalities, we had to shade a certain way, right? We have to do the same thing with linear inequalities. We have to shade. So I'm going to get a highlighter. Whoops, sorry, totally just bumped my little camera holder thingy. Okay, so look at your sign. So my sign is y is greater than or equal to. Okay, and I totally just remembered this point. So greater than or equal to, let's make this note on your paper. Okay, so greater than or equal to, or less than or equal to, just like up here, we put a solid point. These guys get solid lines. So I'm really glad I did that right. So solid line when you have that little extra. Okay, meaning the line that you connect the points to, that is solid. Okay, cool. Now let's worry about shading it. Okay, so shading this guy, our y values are bigger, greater than, or equal to. So where are my y values getting bigger? Which way am I going to shade? Up or down? Which way are they getting bigger or greater than? It's going to shade up. Okay, so whatever that side of your line is shading up, you shade that entire side of the graph. Okay, just like that. So one thing important to remember, look at your sign, because that's going to tell you whether it's either a solid line or a dotted line. Okay, and then you must shade. In this case, y was greater than, right? So we had to shade the y values that were getting bigger or greater than. Okay, let's look at number 6, last example. Okay, we're going to start it the exact same way. So for number 6, what is my slope and what is my y-intercept? Okay, my slope, what is the number or fraction that is right in front of the x? It is 2 over 5. And we don't even have to rewrite that as a fraction because it's already rise over run, right? So now, what is my y-intercept? What is the number that's hanging off the back? -3. So my starting point, right, for my y-axis right there, I'm going to put my first point at -3 on my y-axis. So that's going to be right there. Okay, now I'm going to use my slope to count to my next point, which my slope is rise 2 and run 1. So from our starting point, let's rise 2, 1, 2, and then we are going to run. Sorry, my Band-Aid is like huge. I feel like that's all you guys can see right now. Okay, so we went up 2, and then we're going to run 5. 1, 2, 3, 4, and 5. Okay, if you want to go backwards and put another point, you can, right? That would be down 2, 1, 2, and then backwards 5. 1, 2, 3, 4, and 5. Okay, still a straight line, but remember, now we need to either have a solid or a dotted line. Okay, so this one is just a less than sign. So less than or greater than when there's nothing extra on it. These guys are both dotted lines. Okay, and you can just, don't have to write that again. Okay, so these both are dotted lines. So looking at our sign, is that going to be solid or dotted? That is going to be a dotted line. Beautiful. Okay, so make sure you put arrows at the ends of that line as well. And our last step, we need to shade. Okay, and in fact, I'm going to just, when it's an inequality, right? Because we're not shading when it's an equation, just when it's an inequality. That was hard to say. Okay, so go ahead and make sure those notes are on your paper. Okay, so now we need to shade for our last step. So I'm going to look at my sign. So this says y is less than, okay, less than. So am I going to shade up for my y values or down when it's less than? Okay, I'm going to shade down because those values are becoming less than or smaller. So this time it is shaded on the bottom of that inequality. Okay, beautiful. Notes are all done. They are linked for you on Canvas if you missed anything.